Question 4. Let's solve the system of equations by elimination. But to use elimination, we need the variables to line up. And in this case, the variables are not lined up. So the top equation is 3x equals 2y plus 1. The bottom equation is negative 4y plus 6x equals 2. I want the, maybe I should have written it over here, but that's okay, I guess. I want the x to come first, then I want the equal sign, then the y, and finally the constant. So to do that, to rearrange this equation, I will just add a 4y to both sides. Those 4y's are going to cancel out. Negative 4y plus 4y is 0. So we get 6x equals 4y plus 2. Great. Now I can just rewrite that underneath the top equation. So now to continue with the process of elimination, we also need to make the coefficients the same for at least one of the variables. So in this case, I can just multiply the top equation by 2. That way I get 3x times 2, 6x, and that's great. So 3x times 2, 6x equals 2y times 2, 4y, and 1 times 2 is just 2. Look at that. So we have, oh, that was a little bit, let me just fix this quickly. So 6x equals 4y plus 2. Now look at this. The equations actually match up perfectly. If I were to subtract them, everything would cancel out. 6x minus 6x is 0. 4y minus 4y is 0. 2 minus 2 is 0. 0 equals 0. Well, we know that. That is the truth. That 0 equals 0. It's not like we got something like 1 equals 0, which is not true. In this case, what does that mean? We got rid of the variables completely. That means we have infinitely many solutions because the lines, these two lines represented by these equations, are actually the same. So since they overlap each other, they're on top of each other, they actually have infinite solutions because any point on the line will be a solution to this system. And any line has infinite points. There we go. So the answer is C. Infinitely many solutions.